So now based on the previous video, we can see that if x is constant, so if x constant, so we should put the dx as outer integral where we have a dy dx. Okay, but the second one, when we have y constant, so y constant, we have to put dy outside here, and we have dx dy. Okay, so for determine the limit for dy dx, you need the vertical line, which is x constant. But for y constant, we have the horizontal line, the line that will guide you to determine the limit of the function. Okay, so as in general, the double integral for the function in terms of xy is given by these two double integral where we have dy dx and dx dy. Okay, x constant, so you have dy dx, y constant, you have dx dy. Okay. Okay, so now about how can we determine. Before I give you an example, there is the thing that I want to stress out here, which is very important. Okay, if you have a rectangular region where the function is just like dx, and then you have x and then dx dy, and let's say the limit of x is 1, 2, and then y is 3, 4. Okay, let's say if you want to, okay, for this you can integrate easily with respect to x first or with respect to y first, right? So let's say you want just to investigate whether do we need to do we have the similar answer? So maybe you want to find out by changing the order of integration to be dy dx. So now you have to change the order. So what I'm doing here is I'm changing the order of integration. So from dx dy to dy dx. So since this one is a rectangle, no functions at all. So if you want to change the order, so you just change the location or swap the location. So now you have 1, 2 is outside now because it belongs to x, and the 3, 4 is inside now. So this is okay for rectangular region, which means that all the limits are constant. But you cannot do like that, strictly forbidden for the non-rectangular region. So I mean by non-rectangular region is, as you can see here, okay, look at from the question here. So they give you 30y, the integrand is 30y dy dx. So the limit of here we have a constant limit of x, okay? So x has a constant limit. So 0 to 1, x constant. So y is a function x squared to x. So let's say you want to change the order of integration. Okay, so by changing the order of integration, for the order itself, you can just change from dy dx to be dx dy. But if you just change directly, just swap the location of the limits. So for example, from 0 to 1, so now you put the 0, 1 inside, then you put the x squared x outside. So it cannot be happen like that. So this one is, I would say this is mathematically incorrect, because we back to the basic of definite integral. For definite integral, which means there are limits for the given integration. So the final solution should be a value. But if you have this, and I'm sure that at the end of your solution, you will get the expression in terms of x. So your answer is incorrect, which means that the answer that you obtain from this is not the same as the left one. Because the left one, you will get a number, but the right one, you will get an expression. So meaning that you cannot do like that, just swap the location. So please bear in mind, please keep in mind, this is a very important thing. You can, for non-rectangular region, if your limits are, there are function inside the limit, so you cannot just swap the limit. Okay, but then how? We have to make sure that even though you change the order from dy dx to dx dy, we have to make sure the outer integral should be contains the constant limit. So that is correct, the correct way. You will get a number, a value. Okay, but how? So now from this video, I will explain to you through this example. Okay, so for the example 1 for today, 1. Okay, evaluate. Okay, we just want to evaluate because they give you a complete double integral where there is a what we call that, order of integration given, and also all the limits are given. As you can see here, the limit of y is a function, which means that you will have the region that you have is not a rectangle, which is non-rectangular region, and your x is a constant. But in this case, we don't want to determine the limit since it is given. Okay, so we just want to evaluate. Okay, so how can we do that? So the process is the same as you done for the rectangular, where we settle down the inner integration first. So for the inner integration, in this case we have, okay, I just solve this directly. Okay, where now we want to integrate 30y, then y here, then you can integrate y becomes y squared over 2. So you have 30 over 2 y squared, and then now this is the limit of y from x squared to y equal to x, and then we have to put the x outside, 0 to 1. Okay, so I put y because I know that I don't want to be confused with the x. So this limit is only belongs to y, not x. So that's why, just to remind us, just to let us know that this is belongs to y, not x. Okay, the value here. So next you have to, then we will get 15. Okay, and then we substitute y is x, so you have x squared, yeah, okay, minus x squared square dx. Then when we simplify, you will get 15, and the single integral of x squared minus x4 dx. And as you can see here, your expression now is just x only, normal. Why? Because the y is already replaced by all the limits that we have. Okay, and next, the next integration, we do the second integration where you have to integrate x squared with respect to x. So this will give you 1 over 3 x cubed, 1 over 5 x5. So I should erase that symbol because that is the answer now. So now x from 0 to 1. 0 to 1. So you have 15, and then 1 over 3 minus 1 over 5 minus 0. So 15, 5 minus 3 over 15, and you will get 2. Okay, so this is from the question in example 1. Just evaluate directly. Okay, now let's say you want to change the order of integration. By changing the order of integration, as we done for the rectangular before this, the answer should be the same. Okay, even though you change the order without changing the integrand and also the region, still the same. You have the same shape of the region, so your final solution here should be the same. Okay, so we are expecting that now by changing the order of integration, so the answer also we will get 2. Okay, so now we go to the next process where we want to change the order of integration, where now we have so we don't change the integrand, still the same. Now we change the order, so now it's become dx dy. Okay, as I mentioned before, you cannot just directly swap, right? You cannot do like this, so it is totally wrong. Okay, so then how can we get the new limit for the x and y? So from this, if you want to change the order of integration, you have to have the region first. So they don't give you the curve and whatever function, right? So now this is time for us to explore. But then how can you get the information about the region that you should have? Okay, so actually you can determine the region by using the limit provided. Okay, so in this case, what should we do is, how can you have the region from the limit provided? Because from the question, it's just mentioning evaluate the given integration where the order is dy dx with all the limits are given, but they don't give you extra information, right? So now, how can we do that? How can we have the region? So you have to refer to the limit that you have, but not this one, the original one. So back to the question, the original question here. So now you can have your region by using this example. Okay, so now how can we do that? Firstly, what you can do is, in order for you to obtain the region, to know the shape of the closed and bounded region, you have to read, okay, you have to read the function or the constant provided. Okay, now we look at the limit of x. So we know that the limit of x is constant. So you have x from 0 to y. And then y is from x squared to x. Okay, so then from this in this interval form, we can rewrite them into an equation, into 4 equations actually. So we look at for the constant one here, you can have, from there you can have x equal to 1, x equal to 0, isn't it? And then for y, what is function? Y equal to x and y equal to x squared. Okay, so next, after you rewrite into an equation, into equation form, you have to sketch them. You got 4 equations here, right? You can have the linear equation, this one also linear equation, this one is a quadratic. So you have to combine all the 4 curves on xy plane, on the same xy plane, on the same 2D system. So now we sketch okay, so you got 4 here, right? So normally I will start with the something curvy a curvy line. Okay, not the curvy curve, but a curvy line. So which one is the curvy line? This one, right? This one, the quadratic. So you draw the quadratic. Okay, and then you have a straight line. Yeah, a straight line. Okay, I should use a ruler, right? Okay. Okay, so that is a straight line. What else? X equal to 0. So now you know x equal to 0 is the y-axis. Okay, I should draw it as well. I should use oh no, not that one. Okay, so this is supposed to be green. Okay, and then I have another one. This one. That is x equal to 0 and x equal to 1. So okay, so you x equal to 1. So we should find out what is the intersection point here. So that intersection point, okay, just wonder whether the x equal to 1 should be lying somewhere here, or over here, or over here. That's why we want to check what is the point of intersection here. Okay, so how can we get that? You have to solve simultaneously. You have y, and they will meet. Okay, that two lines will meet, intersect on the same point. So that's why we can say that x is equal to x squared. Remember, you cannot just simplify like this, so it is wrong. You have to factorize first. X squared minus x equal to 0. And then when you factorize, you have x minus 1. And you have x equal to 0 and x equal to 1. So x equal to 0 definitely over here. But this one we are interested to know over here, right? So now we know that the intersection point is actually at 1. So now the line, we have the line over here. Okay, so this one is the line x0 and this one is line x1. And the green one is the line of y equal to x, and the orange one is the curve of y equal to x squared. Okay, so based on the graph that we sketch here, so now you ask yourself, which is the region that we need to shade, where satisfy all the four lines or the curves. So back to the information that we have, we should have a region where it is bounded by the quadratic, the y equal to x, and the line of x equal to 0, and the line of x equal to 1. So which is the region which satisfy, which covered by all these four lines? So have you got the answer? So the answer is, it should be where? It should be inside this. It is very small. Actually, yeah, that is the region that belongs to this example. So actually, these limits are based on this small region inside here. Okay, now you want to change, right? Which means that from the previous from the original order of integration, now we want to check. So you check that x is 0 to 1. So x, so you draw, because we know, as I mentioned before, if you have the x is the outside, that's outside one, then you have to you have the line of, you have the line, what kind of line? Straight vertical line or horizontal line when x constant? Okay, so when x constant, so this is y, this is x. So when x constant, you should have the vertical line. Okay, and as you can see there, based on your limit that you have, that provided to you, so this the pink line is lying between 0 to 1. Okay, and then your y is, what is the lower bound? What is the first point that you can see? The point is belongs to the quadratic. So now the point, the first point, your initial point is that one, which is belongs to y equal to x squared. Okay, and then you keep going upward along the y, and your terminal point is belongs to y equal to x. So are they satisfy each other? I mean that the limit that you are given, to you, is it matched to your sketching? So your lower bound quadratic and your upper bound is y equal to x. So yes, it is matched. So meaning that your region is correct. Okay. So now the time for us to obtain the order of dx dy, which means y constant. When y constant, so now you don't have the vertical line anymore. So now back to the question here, we want to change the order dx dy, where y is constant. So since y is constant, now you don't have the, what color? Just a second, I want to erase. So you don't have this anymore. Okay. Then you have to sketch the horizontal line. And as you can see there, this line is lying between, since you know that that one is located at x equal to 1, can we know the value of y? So when x equal to 1 for both lines, so the y will be the same, right? Which is y equal to 1. Okay, so now you can see that the limit of y and y constant is from lying, this line, the blue line here is lying between. So this is the smallest y. This is the highest y possible, the highest y, which is 1. So y is from 0 to 1. Now we want to investigate what is the limit of x, which is a function. Okay, so back to your vertical line that you sketch here. Okay, so now you are walking along the x-axis using this line. Okay, you're walking to the right, and then what is your initial point? The first point that you have lying on the region. So this one, right? This one. So that line belongs to which equation? Which curve? The green curve. So what is the green curve? X. Now you have to read x equal to. Okay? Because now you have x is the function. So now you just, instead of you have y equal to x, now you just have x equal to y. So you have x equal to 1. Okay, now you keep going to the right, and you're walking along this line, and finally your terminal point. So now your terminal point is here. So large. Is over here. So that line, that point belongs to which curve? The orange one. So the orange one belongs to y equal to x squared. But you want to have x equal to, not y equal to. You should have x stand alone, just x. Meaning that you have to rearrange this equation because you want to get x. X is the function of y now. So how can we do that? So you just rearrange. So then you will obtain that x is square root of plus minus, okay? Plus minus square root of y. Okay. But now since you have two values, whether positive square root or negative square root, now you have to look at your region. So where is your region lying on? On the first quadrant, right? On the first quadrant, which means that y positive and x positive. So because of that, you know that this lying on the first quadrant, so the x here should be positive. So we just consider the positive. Okay, now you have x equal to square root y. Okay, so I repeat, you walking along the x-axis. So when you're walking along, you go to the right side slowly, and the first point that you have is part of the green line. So what is the equation of green line in terms of y? So x equal to y. So you write down here x equal to y. And then you keep moving, walking along the x to the right. And then your terminal point is here, which belongs to the orange curve. So what is the orange curve belongs to? Quadratic, right? But from the original expression, you have y equal to x squared. But in this case, you have to get x equal to. So you have to rearrange. So instead of we have y equal to x squared, now when you rearrange this, so you have x equal to plus minus square root y. Okay, since you have two values of x here, you have to look at your location of your region. So your region is lying only on the x positive. So we just choose the positive square root, which is just square root. So that's why we got this one. So now that is our new limit. Okay, where now we can rewrite the double integral to be, so we don't change the integrand, but we change the order, which is now dx dy. So the limit of y 0 to 1, and then x y to square root y. Okay, so now we can, now we got a complete set of double integral. There is order of integration, there are limits. So now we can evaluate. Okay, so now to evaluate this, so you got here a simple expression. It can be easily integrated by respect to x first, or with respect to y first. So just now from the original question, we integrate first with respect to y, and we got 2. I mean the final solution we got 2. So now we are expecting that the final solution also 2. So now you have to integrate this with respect to x. So since the x is not here, so meaning that 30y, they are all constant. So when you integrate 30y, so it's become 30y is constant, and you just have x. So the limit of x is y to x equal to square root y dy. So you can take out the 30, then just substitute. Mana datang set pula ni? So sorry it's fine. Okay, and then you just substitute. You have square root y minus y dy. Okay, so now your expression just in terms of y, no more x, because the x is already replaced by the limit that we have. So now we integrate. Do you think we have a problem here? You have to integrate this expression. We have no problem, right? But you have to expand that one first. So 30, and then okay, when you expand y multiplied by y half, so you have 1 plus 1 over 2, so we'll give you y equal to 3 over 2, right? Yes, 1 plus 3 over 2. Okay, so now you have y 3 over 2 minus y square dy. Okay, and then integrate this. Okay, so the expression looks messy, but still can be integrated easily. You have 3 over 2. When you integrate 3 over 2 plus 1, so you have this one. So yeah, 3 over 2 plus 1 divided by 3 over 2 plus 1, and this one y cubed over 3. And then when we simplify this expression, so we have this, and we replace the limit of y is from 0 to 1, and finally we got 2. So the answer is the same as the first, as we done in the first one, this one, okay, the original one. So we got the similar answer. But as you can see, the second one is a bit longer, because there is a, in the limit there is a square root, but it doesn't matter, still can be done. Okay, so I give you the first example where you need to change the order of integration. Okay, don't worry, I will give you another another few examples that I'm sure that you can understand from time to time. So I'm sure that it is good if you can just replay again and again and watch again and again on my video.